we were just testing micro. That wasn't a snap, like, with the fast things. So. How you doing? Good. So our next speaker is Angelo Prado, and he's the Senior Security Manager with Salesforce.com, and has worked as a software and security engineer for Microsoft and Motorola. Angelo's been speaking at security cons for over 8 years, including Black Hat, Hacker Halted, TourCon, Sector, and G6 Minds, if I'm pronouncing that right. Seems to me to be the logical way to say it. Passions and research include web application security, Windows security, browsers, machine learning, malware analysis, and Spanish Hamon.
Yes.
Yes, excellent. Nailed it. So please welcome Mr. Angelo Prado. He's going to talk about practical side channel attacks on modern browsers.
Thank you. Welcome, everyone. My name is Angelo, and I'd like to do a small introduction before we go on. But before my introduction, let me tell you what we're going to talk about today. We're going to talk about how to bypass cross-site scripted filters. We're going to talk about timing attacks with same origin policy. We're going to talk about data URI attacks. If you do not know what data URI means, don't worry, I'll explain it. We're going to talk about how do we steal the history from your browser. We're going to talk about how do we steal clipboard from your browser. We're going to talk about how we use Flash and compression vectors to steal information from your browser or encrypted communications between your browser and your web server. So it's going to be a technical talk. I'll do my best to cater to everyone here and explain all the details as much as I can. But before that, I want to give you background. So I was born and raised far away from here. I'm from Spain. Just for reference, Spain's here. This is Mexico, and this is South America. So, with that out of the way, Spain is a beautiful country. Thank you guys. I never been to Alabama before, so I'm very excited to be here. It is very green, but you know, Spain is also a beautiful country. We have beautiful wine, Spanish Hamon. You know, we're internationally recognized for our research. Yeah, our soccer team didn't do well. That's last time around. Yeah, we have very hardworking people, as you can see. Here's a, you know, construction side. So, you know, human resources, marketing, logistical, you know, communications manager, security, you know, product manager, supervisor, engineer, developer, product owner, and you know, this is the guy that works. So, you know, so when I was growing up, I learned about advanced persistent threats. Yeah, it can get iffy there. You know, we a little bit behind the times, so we like to do things differently, or some people do. And they, you know, they don't know any better, so they put themselves in front of the bull. So you know, they experiment with what I call injection attacks. There's also privileged escalation in Spain. You know, it's something that the bulls do very well. As you can see, this is a very technical talk. And of course, denial of service. You know, which is what happens when there's a bunch of drunk people that get in front of, you know, 4 bulls, and of course the bulls are going to run over you because, you know, that's what bulls do. They don't know any better. You should know better. You know, one day I sat alive and I figured, you know, I really should look into side channels. So first, to get the cons built, I had to get here to an airport, and I work in San Francisco right now. So there was a bit of a line. So, you know, what hit me the other day, I wanted to understand how this boarding passes work. So, you know, let me show you an example. American Airlines doesn't have mobile boarding passes, unfortunately. So I'll show you with Alaska Airlines. So this is what you get when you get a boarding pass. Alaska Airlines boarding pass, Seattle, Oakland. So there's this funky file, which a computer running Windows cannot understand, but if you were running this in an iOS, you would have what's called a mobile boarding pass, basically. Now, if we open this with Notepad, it's kind of useless. The good news is if you open it with WinZip, it becomes a perfectly valid file. So this is what the airline is delivering via website or email to what happened? Okay, to your to your phone. So it has the icons, and it has a very interesting file that's called pass.json. And let me see if we can prettify this. Let me name this bigger. And this is not the core of the talk, but it's the story of how I got here. I thought it was interesting. So we put it here, JSON. It's going to make it pretty invisible. So anyway, here's the JSON, and let me see if we can put it in Visual Studio now. And I can open it for you. Oh, you know what? I messed up. We'll put it in OneNote, in Notepad. So here it is, flight number, departure airport, Seattle, work gate, traveler, right? So here it says loyalty number. This is where it has your frequent flyer number. So all you have to do is, just because this is something you show to the agent in the gate, and they will scan manually. This is not built into the scanner. This is a manual process. When you want to go through a priority line, all you have to do is just type priority to the board. It's pretty basic. It's not advanced hacking, right? I told you guys it was from Spain, so so sometimes you have to go priority. All you need to do is just change the thing to JSON, and the boarding pass Thank you. All right. And it works. Let's try it out. You can also use Photoshop, but the whole point is when it's kind of your boarding pass, the only data that's in the QR code is your flight and your name. It does not really tell you if you're a priority or not. Of course, this does not mean that then you can go into first class, because if you modify your seat and someone else is sitting there, it's a problem. But there's software that allows you to see whether the seating availability is going to play. Well, you get the idea. So anyways, all right, you guys are fun. Bypassing, okay, let's talk about XSS. Who here knows what XSS is? Please show hands. Okay, some people. We're going to have to work hard today. All right. So XSS is it's basically XSS is a process scripting attack, and what a browser will do is, if it finds an XSS vulnerability, it will protect you from it without you even knowing. So let me give you an example. If you say we had a page, let me make it bigger. Okay, so have a page like HTTP bankofamerica.com/view balances.jsp. This is all just fictitious, hypothetically, and then as parameter equals the script src evilhacker.com. Right, this is evilhacker.com is HTTPS, just like Bank of America. You get the idea. Evil.js, what will happen is this JavaScript would be injected on the page, and then evilhacker can sure enough read your balance, date your session. It's effectively living inside of your page, just like Google Analytics would do. It's a script. And what will happen is they can steal your session, your credentials, do transfers on your behalf, show you pictures of cats if they want to, but typically not what happens. So the problem is you get an input, you put it back on the page. It's a pretty well understood problem. We've been 15 years with this problem. All you do is less than, greater than, and basically you replace it with brackets. Fantastic. So I forgot to start my timer. Okay. 1 second. Yes, that will do. Okay. The problem is they're not that strong. There's ways to bypass them via DOM-based XSS or persistent XSS. But the interesting type is the reflected XSS, which we can actually bypass under certain tricks. So let me show you a demo. This is the second demo today. So we're going to open Chrome. Here's a this was easy. Okay, so this is a way to bypass it. So you have something like ID equals blah, and you look at source code, and there's a JavaScript literal, right? And then if you put something like single quote plus alert document.domain, the syntax needs to be correct, so you might need another single quote. You see, like, plus is getting converted in space, it's not working, but if I could get a plus in there, which is basically going to be a percentage 2b, I think. it will work, even though, so you can see it's popping up, and it's just an alert, but I could do anything at that point and run the JavaScript inside the page. So this happens because, and I do not have the Chrome filter access disabled. This is the default filter. This is happening because fundamentally it's a string literal. I'm not detecting any new script nodes. I'm just concatenating the alert. So that's pretty easy, but sometimes it gets harder. Let me show you. Bypass.php. Okay, so ID equals blah. So you notice that I put a script alert on the ID in this case, just to show you the different example. And it's not executing. And the reason it's not executing is because Chrome is filtering it. If I put like a B tag for bold, you see that the text becomes bold, but it's not executing any malicious code. So the script is being filtered out by Chrome. And if you run it into IE, Internet Explorer, you will see the same behavior. In fact, IE will tell you, Internet Explorer has modified the page to prevent XSS cross-site scripting. All right. So here's what we're going to do. We're going to do something more fun. We're going to say, we're going to do a different payload, which is basically going to be like script alert. This is just some coding. Script alert XSS document domain, and we're not going to close the script. Sure enough, this is the latest version of Chrome, by the way. This will work. And this is working because you have a script over here that says alert. Chrome is looking for open script, close script. But conveniently, there's another closing script later in the page, which belongs to the page. So it just kind of executes this line and then says, oh, I don't know what this is. This is incorrect. Oh, I don't know what this is. This is a function. And here it closes the script. So all I injected is this one line. I didn't actually close the script. I relied on the page to close it. And as a result, it basically runs my HTML injection. So there's other fun ways to do it if you want to use what's called an SVG. I was supposed to type this here. Okay. So evil hacker bypass.php ID SVG. So this is an SVG file. And what that is a vector graphic which has a link to a function inside the SVG. And why do SVGs allow JavaScript? I don't know, but that's basically the same reason why Flash and PDF allow JavaScript. It's a really bad idea. Probably the French that came up with it. Maybe Spanish. So it's a bad idea, but it allows you to have an SVG, a vector graphic that has an href, and then it has a script inside. And what happens when you click it, where was my link? Let me just move the view source here. What happens when you click it? I think I messed up. Let me copy it again. I know what's happening. It's too short to copy in the run window. I need to copy the URL bar. Okay, there you go. So that's the whole thing. And what happens when you click it, it has a link. It says link href JavaScript or location. And this is inside of the SVG, and it's not being filtered by the browser. So when you click the black box, we're running JavaScript. So that's fine. Now, Internet Explorer has the XSS filter as well. Let me show it to you. It's enabled by default for all users. And there's also fun ways to bypass it. So if you don't know what I'm talking about, the XSS filter is here. Enable XSS filter, you can see it's enabled by default. So let me show you how to bypass it. There's many ways, but here's one fun way that I found to bypass it. So XSS bypass.php, x equals 1 plus or false. It says, modify the page cannot run. So you will notice, let me zoom in for you, you will notice that it replaced the, you basically replaced the braces or the alert with a pound sign. So, no dice. You have a black. Now let's try something else here. What if we put, instead of a brace, what if we put, we do the following code? This did not trigger the detection, but it did not execute anything useful. So let's look at source code. So here's what we're doing. X equals 1, right? So here's the input that's being reflected. Alert, comma, and this semicolon. This should be a semicolon, not a funky looking colon, but you get the idea. So what this is doing is said x equals 1 and x equals alert. So it's redefining the x function to be alert. But it turns out that's not allowed. You cannot do that once the function is defined on modern versions of IE. So it's a protection that will not let you do that. But if you go to compatibility mode, just do an F12, you change IE to version 8, you can see it executes now, right? So, but I'm attacking myself at this point. But there's something really fun that an attacker could do. Let's say that I'm an attacker, and I have a malicious domain like evilhacker.com. I actually own that domain, so if you want an email address, you can talk to me afterwards. And access bypass.html, evil hacker, boom, so it's running access. So let's try to understand what's happening here. Evil hacker is iframing malware.net. Okay, so this thing over here is an iframe with the payload that I told you before, which is basically redefining the X function. What's happening though is there's a very interesting line at the beginning, which says emulate IE7. Basically said, oh, I want you to load this vulnerable page, and I want you to load it in the most vulnerable possible way. And I want it to iframe it for me, right? So, you're an evil hacker, but right here, if you click properties, this is going to be, you can see this is the order domain malware.net. And it executes because it's basically running in compatibility mode, because the parent evil website is forcing the underlying site to load. So, this opens up the tags that are very interesting, like CSS expressions, things that rely on compatibility mode. You can force the page to load in compatibility mode if you iframe it, because it will inherit the rendering mode of the parent. And all you have to do is put a header that says emulate IE7. So that works. Okay, so enough with XSS, and what did I just do? All right. Okay. So, timing attacks. So, this is very interesting as well. It turns out that, JavaScript browser engines run in a single thread. There's no multiple threads. What this means for you is an iframe, as well as the parent and the child. So the parent window and the iframe child are all running the same thread. We can bypass the origin policy by keeping the JavaScript interpreter busy. And malicious attacker can keep track of frosts and delays, and you can figure out what are you doing in different situations. So if you have something that relies on checking your password, checking string, or regex on the client side, we can run code every few milliseconds, and we can see if your code ran or it did not run. And then depending on that, we can time it, and we can figure out what your secret is. And I know this does not make a lot of sense, but I'll show you a demo, and hopefully it'll be easier. So here's a demo, evil hacker, origin.html. You can visit your browser later if you want. So you see we have a timer right here. And I'm going to click stop all the things. And what's going to happen is the timer is going to stop. So watch this. So the timer is stopping because it just went into a while loop, basically for 10 seconds. And it's going to come back, and the timer continues. So we'll do it again. Time stops. The browser's kind of frozen. 10 seconds, and it just comes back. Right? So we have evil hacker at the top, and we have malware.net, which is a different domain at the bottom. You can see view frame info, this is malware.net. And if you look at view frame source, what the source is doing is it's just doing it's listening to the parent for a post message. This is pretty common on things like OAuth or cross-page communication. And it's basically when you have one domain talking to another without a proxy, just using the post message. And it's doing a regular expression to see if you basically send it a secret, and it's doing a regular expression to see if the secret is correct. So only malware.net, this frame knows the secret. The secret is randomly generated and refresh the page, it's going to be a different secret. So only malware.net knows the secret, and evil hacker wants to figure out what the secret is. So what evil hacker is going to do, hack one around. So what it's going to do is going to send a regex to malware.net that says, hey, I think the secret is 0 point, and then a bunch of, basically a bunch of numbers that are repeated. In this case, 0.0000 repeated 100 times. Eventually it goes like, I think the secret is 0.6666 repeated a bunch of times. And it does that quite a lot of times, and what that means is when you get the right secret, it will be able to determine, so the page at the top, which is in this case the hacker, will be able to determine what the secret is. Why? Because it can time the amount of milliseconds that it took you to process that regular expression. So if you were doing a comparison, it would be much harder, just like a string comparison, but it is doable. It's just much, much harder. You need to do it many more times. But the point is, when you look at the secret that starts the right way, 0.6, then the browser will do one additional comparison, because it will check if the next digit is also correct. This is the way comparisons work, right? If you have 0.6666 equals 0.6. So it turns out that out of the two comparisons, the first one is going to take more to execute, right? Because 0.6 equals, so here it's going to go, oh, 0 matches, 6 matches, so it's going to go to the 8. But here it's going to build on 2, so the first comparison is going to take longer. So if we do this a million times with a regular expression, what we can do is we can time the secret. So the top page is able to determine the number. So let me do another round. I'm going to bring this to the top. And you'll see in the title that slowly, as I click buttons, figuring out what the secret is. 0.66, 6, 4, 5, 7, 9. Eventually, sometimes it gets wrong, like you got 0 wrong, you should have been 6 because it's not perfect. And the time is decreasing, you need to do more regular expressions. So you can see the idea that by sending regular expressions and timing how long is the iframe taking to execute the query, we can determine the right number. And all the top page is doing, and I'll show you the code, all that is doing is basically saying, give me the time right now. And it's doing a post message, and it's just determining when was the last click. And because it has a shared thread, it knows exactly how long it would come back. And it fundamentally is able to determine which one was bigger, and with that information you can guess what is the right character and move forward to the next one. So something to be mindful of for string comparison attacks. Alright, so moving on to another very fun, very interesting thing, which is browser clipboard attacks. So there's two ways that you can still use those clipboard. One of them is via CSS, where you secretly override the content of the clipboard, basically by hiding partially the view of what the user is going to copy. So you're going to partially hide what the user is selecting, and when he selects it, he's selecting more than he's signed up for. And I'll show you that in a second. And the other one is a JavaScript, basically intercept when the user hits the key down, and you manually change the selection of the user, and then you wait until he copies it, and then you restore the selection. So via JavaScript and CSS, you can modify what the user is copying. So when he thinks he's copying something, he's copying something else. This is particularly interesting, and I'll show you a demo. This is the demo that I have over here. This is particularly interesting if, particularly interested in pages like Stack Overflow, where people just blindly cross what they copy and they put it in a console. So here it is. You surely know this, you're looking at some website with some useful shell commands. Those commands are long as hell, so you're not going to type them, you're just going to copy them, right? So what do? You basically select the text and you trust that what you see is what you get. Let's see if I can select it. Okay, so right click and copy. I could just do Control-C, but this is where you will see my copying it. And now I open Notepad, or I could open a console, and I paste it. And what you end up is with something that's, let me see if I can drop it. You end up with a malicious script. In this case, calling that null, echo, who am I, that was the idea, don't copy code from websites you don't trust, here's the first line of your etc password file. So if you execute this, it would do something bad. Now, the way this works is basically with the page source, and it has a hidden div between git clone and the actual and the actual URL. So in between these two characters, there's a hidden div that contains the malicious code. So you go git clone, and here's dev null, so that is a null command, this doesn't do anything. And then here does the malicious stuff. This is hidden in it's basically in a span that's out of position, it's outside. It's 100 pixels to the left of coordinate 0 and 100 to the top coordinate 0. So you do not get to see that div, but when you select it, it comes as part of the selection. And then it just finishes out like here. So you copy it. Again, if you copy it again like this, and you end up copying more than you intended. So this is with CSS. And the other way we can do this is to sort of lie to the browser and the user is with JavaScript. So here's an example. So I'm going to select copy me, and when I click Control-C, because nothing happened really fast, and I open Notepad and I paste it, says, wow, you can't copy me. So something changed, right? Now if you see what happens, I'm going to do this slowly. When I hit Control, see, it's actually changing the selection, putting something else. And that could be white font, so you wouldn't see it. The only reason you see it is to show you the demo. That could be white color or white background. You would not see it. But it's basically changing the selection. And as I hit Control, so I can select whatever, it doesn't matter. It will change there. I will hit Control-C, it will disappear. And when I paste it in Notepad, you will see what the attacker intended to copy. And that's using JavaScript. And if you look at the source code, all it's doing is listening for a key or key down. And then if the key is Control or a meta key for Mac, it's going to display the malicious data that we want to copy. And it's going to add range. Range is what means selection. It's going to select the whole text that we want to copy. And then you as the user, the victim, are the one that's actually copying it. You are doing a Control-C. It's just the browser or the malicious page of the browser is changing your selection underneath without you knowing it. So that's pretty cool. So that's how you fake clipboard. All right, what else? Oh yeah, let me tell you about login and history site channel. So brief explanation of what this is. Login detection is having the ability to detect if a user is logged into a bank or an email provider. Why is that useful? Well, because I can then run certain attacks against you if I know that bank is vulnerable, or I know that you use that so I can target you. So it's useful both from an attacker and from an advertiser. It's basically knowing from a third-party website like evilhacker.com to know that you're logged into PayPal. And history stealing is basically similar, except that it's knowing that you were or are logged into PayPal, but not necessarily now, but you frequent that site, so we can target you accordingly. So let's see how this works. In 2006, Jeremiah Grossman, one of the greatest hackers of all times, he came up with a very simple yet useful way to run this attack. And what he did is he renders a bunch of links on a page for all the top US, world, Alexa, top 100,000 sites. And he renders them. Of course, you wouldn't see them because he's rendering in the demo, but in the real world, it would be hidden in an iframe with 1 pixel width by 1 pixel height. And then if you look at the color, and if the color is purple, no CSS, so by default is blue or purple, that's the browser behavior, then it means that you visited it. Otherwise, it means you didn't. I mean, this looks pretty basic. Again, it's like Spanish scientists. So, Mozilla they fixed it, and what they did is they constrained the tagging available for visit the selector. Essentially, you can only specify the color, and not only that, but when you query via JavaScript, what's the computed style, what's the computed color, what's the calculated color of a given link, it will lie to you. The browser will lie to you and say, hey, no, this color is totally blue, and it's purple, but no, it's totally blue, because we don't want you to know if it was visited or not. So, and you cannot do anything fancy, because other people will know, oh, you logged in the color. Well, we're just going to do, CSS animations. We're going to border the links, and we're going to make them, spin around the page in 360, and then we're going to time how much is the page taking to load. And they took away all of that, so that does no longer work. Limited visibility of the style attributes through APIs to get computer style, so you cannot do anything. You cannot get any details in the color of the attribute. So this is the demo that used to work and no longer works, because it was fixed, like I said, 6 years ago or 5 years ago. So you can see Amazon, Apple is in red. And the demo, this page was supposed to predict which ones you visited, which ones you didn't. And when you visit a link, you can see those different colors. But the page has no access to the color. Again, through JavaScript, the attacker cannot tell the difference between red and blue. And links. For everything else, he can, but for links, the visited selector, he cannot, because the browser is blocking it. Therefore, your browser is no longer vulnerable. We all go be happy for the next day. Except that we have a long history of ignoring vulnerabilities that do not yield complete breaks. And what that means is there's always side channels, and that's what I'm here to talk about today, side channels. So encrypted response size is one of them. Basically, if I'm in the middle, I can forward your query to PayPal.com, and if I know what a normal query for an authenticated user looks like, and what a query for a non-authenticated user looks like, I can determine, hey, this query is authenticated because it's bigger, this query is not authenticated because it's smaller. That's just one way. But that requires me in the middle, which is kind of hard. Another one is cross-domain image size. This is a really fun one. Internet Explorer caches image size of known resources. Bear with me for a second. What did it do? Okay. I think that you hit B, it goes black. Images that have now been loaded have the default 28 by 30 size. Therefore, if you never loaded an image of the internet and I tried to load it, before it renders, it has a predefined size of 28 by 30. You guys know the X symbol when there's an image that cannot load? That is the default size of that X. That's 28 pixels by 30 pixels. And this is what's fun. We can examine the width and height and cross-domain image resources across tabs. So what this means is, if I'm an evil hacker, I can just read the HTML code of PayPal. That's the same origin policy. It's not like you do that. That's not how the internet works. You cannot read source code from our website. But you can sure put an image that's hosted on PayPal beyond an authenticated wall, and if the image loads, you can determine the size. You cannot determine the context, but you can determine the size. And that's useful. Let me show you why. So, logging in here, evilhacker.com, login history demonstrate, and say, there's an alert here that says 200 at 232. Said logged in or was logged in. And this image is being loaded from, from my employer and Salesforce in this case, and it's my profile image, right? If, and all I have here is some code that basically goes like, get the element, if the width is 28, I'm not logged in, else logged in or was logged in. Now what's interesting is, let me open it in a new private window so you see what happens when I'm not logged in, right? So this is the incognito mode. And you will see that there's an X that says 200 by 232. And that is because it was cached, even in incognito mode. I mean, I did not even know this was going to happen. This is pretty impressive. So I'm in private mode, and see if I select the image, you can see it matches the size, even though it cannot load it. So just by looking at the image, you can determine if you were logged in or you weren't. You see, if I go to Chrome, where I'm not logged in to Salesforce, same URL, it will load with the default size, and it will say, okay, that's because it has the code has a bug, and the size in Chrome is different. Remember how it was 28, in Chrome is 15 by 17, the actual size. So, but you can basically get the idea that instead of checking width equals 28, I would check width equals what? I would check in this case if equals 15, and based on that I can determine if you're logged in or you're not. But what's interesting here is, remember guys, I opened a in-private window to the same demo, and this is the same URL that I have in the other window that's authenticated. Let me copy the URL. I do not have access to this URL, so you can see if I try to access it, it will not load. I don't know what's happened here, but it's setting me login because I'm not authenticated. But it remembers the size because it's in the cache. And I can order the size for an image that's hosted in freaking Salesforce, or it doesn't matter, it can be anywhere in the planet, from evilhacker.com. And by looking at the size of the image, I can determine if you were logged in or not. The only condition is that that image has to render only when you're authenticated in the site. So it's basically the image is protected. So let me show you another example of that. Let's move on to another example, event-based loading. So imagine you have some sort of a script or an image behind authentication. For example, a URL that does not require object enumeration. So what I just did is because I knew the object ID of my profile, I knew my profile number, which is an incremental number. So what would be a good idea what would be a good example? So for example, the default profile avatar would be a good example, because that image is always going to be there, and it typically has a static path. So let me show you the demo. Demo 4. So this guy says no good. right? And let's see what happened in the code. It's trying to load this page here. Let's go here. This is not logged in because I'm not logged in, right? So it says, you know, it failed. So it's not in. Now I'm going to log in. And again, this works with any system. I'm just showing you the results because I happen to hear, but work for them. But this is an internet problem, not a Salesforce problem, so to speak. And we have here a profile photo. I'm going to, you can see the default profile picture, and you can see it's a static route. Like this path is not secret, it's predictable. So now the attacker is going to try to load that path from the evil hacker, and it's going to load. And depending on whether it loads or not, it's going to trigger different events. If it loads, it triggers an all load. If it doesn't load, it triggers a non-error. So that's no good, and sad keyten appears. But if it loads, it's going to say all clear, and it's going to put a different picture. So let me load it. All clear. And you know, you can see that we can detect this. So we can detect if you're logged in. That's pretty powerful. But there's more. There's more. Let's see. Timing with heavy quarters. So you said, well, what if you don't have an image that's behind authentication? Because this is kind of a edge case. Okay. Sure enough, you will have a page or a servlet that takes more time to return the regular static resource. What this means is you will probably have a page that lists your users or search something, right? You probably have a search page in your product, so we can send different searches of different complexity, and that's going to take longer to return if you can do the search or if you can't. So if you can't, it's going to send you to login, or it's going to fail outright. It's going to say, you know, 403 unauthorized, or it's going to 302 redirect you to login. But if it succeeds, it's going to give you a few hundred OK. And it's going to send you the result back. So we find an image we find a page that takes time to return. We load it as an image, and I know it's not a page, but we load it as an image, even if it's not allowed. We don't care if it doesn't render, it's not a loaded image. All we want to know is what is the download time, what is the speed at which the image got rendered. How do you determine that? You listen for the on-error event. You fight for bandwidth and round trips. So let me show you that. So here's another demo. We're going to use Internet Explorer, and we're going to make sure we're not logged in right now. Okay, we're not logged in, so I'm going to go to Evil Hacker, Demo 5. Your connection speed is blah, blah, fail. You're not logged in. I refresh it, you'll see connection speed is fail. I'm going to log in, and basically it's going to measure how much time it takes to fail on that particular image, except that again, it's not an image, it's a freaking request to a search page. If you look at the source code, all it's going to do is going to Salesforce and going to search results, string test, with a mathematical random number, so every search is different, it's not cache. So I'm going to refresh this page now that I log into Salesforce. It says your connection speed is 0.69. That's over 0.5, which is my threshold right now. So you kind of have to play with the threshold, but I knew that was the case. So, you know, over 0.5 means that the query actually got executed. So you're logged in. So I was able to detect you're logged in. You know, and there's other ways. There's this other gentleman called Michael Selesky that came out with something really fun, which is this game. It's kind of silly, but you know. I love playing games here on stage. So what you do is you have to, okay, I'm going to start a game again. I'm not good at it. What you have to do is, you know, you have these asteroids that are coming towards you, and you have to kind of kill them. And you might be thinking, this is really silly, Angelo. What are you doing here? So the funny thing is, these asteroids actually are hyperlinks that, depending on whether you visit it or not, they have a different color. So the browser cannot tell the color, but the browser can tell if you shoot at them. So if you shoot at them, that means you can see them. If you don't shoot at them, that means they're black and you cannot see them. Someone is picking out the joke. So basically, boom, here you go. And we're done. So as you visited Amazon.com, Twitter, Bank of America, Bing, eBay, and now this is the one that's right. So what's happening is there's a bunch of asteroids that came to me, but only the ones that I visited were in pink or purple color. The others were black, on black backgrounds. So I cannot see them, so I do not shoot at them. So depending on whether I click on the links, that is, I shot the asteroid or not. The page is able to determine if I visited the frequency or not. that is a pretty clever idea. Must be the French. Canadians. Alright, so that's a pretty clever idea. Just, you know, it requires user interaction, it requires the user to play a game, right? So there's something else that you can do. This is the last trick on stealing history. You can use the requestAnimation frame JavaScript API. What the hell is this? Well, too much information, but it basically tells you how many frames per second you have in your browser. It's useful for animations and like, you know, canvas and stuff like that. So a function is passed to you that tells you before something is painted on the screen, it tells you when it was called with timestamp. So you can measure how many things are being rendered. You can basically measure how fast are you rendering a page. And this is a feature, not one of those. It's a feature it's used so you can have, you know, things like a Rubik's Cube and, you know, HTML5 is why not? You can do, you know, Rubik's Cube. So this is just an example. But the point is that you have the ability to determine the internet's results, right? Or something else. So you have the ability to do animations. You can measure the time. I wanted to show you an example where the patch is down, like a HTML5 Rubik's Cube. This is how you do it. You basically go like loop. Here's the delay, here's the frame per second, update animation, requestAnimation frame loop, last time equals time, and basically you will know the delay will be updated because after you request the frame here, last time is going to be, requestAnimation frame is going to block you, and when the frame is rendered, last time is going to be updated. So you can tell how much time was in between last time and delay, which is the initial last time, and in a rolling way, you can figure out how many frames you're rendering. So that is useful because we can slow down rendering with links. How do we do that? Well, we do, CSS3 has a new feature called test shadow. You can drop shadow, you can emboss in blur radius. You can be very artistic with your links. You can put borders, you can put 3D. And the down rendering time is proportional to the values. But of course, the values will depend on how fast your hardware is, and it will depend if you're connected to battery or not. So we need to slow down the rendering so that we can check several links. We basically render several links, and the ones that are visited are going to have all these wonderful effects. They're going to have border, radius, they're going to have drop shadows. The ones that are not visited will not have any of that. So we will measure how, and we not only render one link, we'll render the same link a million times. So, you know, it takes some GPU processing, right? Just for fun. So let's take a demo of how that is done. Let's look at demo. So here's an example. You click start, and you see it's going through a number of different URLs. You will notice that some of them are blue, some of them are purple. The purple ones, you will notice, they have effects that allow you to, they have more transformations. They have a blur radius, and you will notice that the blue ones are pretty plain, but the purple ones, there's some sort of blink and some sort of background color. That is basically the blur effect. It's blurring the whole thing out. And by blurring it, it's taking more time to render it. So the browser is right now calibrating. We're in evilhacker.com still, so you can see. And the browser is going through different sizes of links. And all of these guys are the same link. For example, when it has correctly YouTube, you can see the bottom how it's moving through. It's hard to see from the back, but it's moving through many different links. And it was able to, based on the time that it took to render, it was able to detect if I visited one or not. For example, it knew that I visited Salesforce, it knew that I visited login to Salesforce. It knew that I visited Google, Google UK, Stack Overflow, and Bing.com, right? So every single link that's purple, it was able to say visited next to it. So it was able to calibrate that. Again, because when you visit the link, it's applying a CSS transformation. So that's taking longer to render, and it's basically measuring the time to render. Therefore, it can calculate that it's actually visited. And it's not just doing it once, as you see, like for example, this is Ars Technica right here. So it's not just rendering it once, it's basically put in a boatload of links. So it will take more time until it can calibrate what's the amount of links that it needs to proceed at a reasonable speed and then figure out which pages you visited. So that's pretty fun, and it's just done with timing. So let's talk about something else. we were talking about flashless side channel. This is very interesting as well. You can use flash to bypass same-origin bullets in certain ways. So let me show you how this works. Imagine you have the ability to upload a picture on your page, right? Like a avatar or a profile picture, or maybe an attachment. Anywhere you can upload images, you're potentially vulnerable. And the way this is going to work, I will show you a demo and then I'll show you how it works. So what we're going to do is we're going to use Internet Explorer, but this works in Chrome as well. And we're going to go to this website. It's called User Profile. And this is the malware.net, right? User Profile.php. Confidential information goes here. This is a sample. There are many websites that have this problem. I just crafted one myself so you can see the sample. Right? So nothing else but a confidential text. Now this page requires authentication. So if I open FieldWork, which is a traffic capturing tool, you can see that I'm sending a cookie called session ID Takedowncon demo. Right? Okay. So that's basically what the cookie is. And if I go to this other website called profilepicture.jpg, this is the profile picture I uploaded for myself. Or for a different user. You can see it's a picture, but it didn't load properly. If you look at the source code, there's no source, it's a picture. If you look at the JPEG here in FieldWork, you will see it says content type image JPEG, right? And there's some sort of funny thing. Well, it's really not a picture, it's a flash file masqueraded as a picture. What's fun is it's been served as a content type image JPEG, because the server says, no, this is a picture, it was uploaded to me with a JPEG extension, but the contents of the file are flash. And the flash file is going to grab some data from you, in this case, all the data in the page, all the confidential information, and it's going to send it to your little hacker. Right? So how do we do that? So let me show you the example. So this is going to be the malicious URL that I'm going to use. I'm going to delete all the traffic. So I'm going to a different domain. It's not even a domain, it's an IP address. So that tells you that it's malicious. And it has the word evil on it, so it tells you it's double malicious. And it's a PHP, so it's triple malicious. Right. And AP is probably in France, so it's, it's actually in Dallas, Texas. It's one of the data centers in Austin. Okay, so we go to this URL, look at the traffic. So it went to the PHP site, right? Nothing happened. The victim did not see anything. Went to the PHP site and got some code. I can actually open the code here in the browser for you. And the code is basically saying, hey, browser, I want to open this flash file that's linked into a JPEG picture. Okay, so yeah, I totally want to load this picture that happens to be a flash file. And you can see right here. And there's some variables here. And by the way, I want you to go to this site, malware.net user profile PHP, and I want you to exfiltrate it to a completely different domain called evilhacker.com. And do not ask me why, but this actually does work. And what's scary here is this JPEG is actually a flash file. When the flash file runs, it's not running under the IP address, in this case, the malicious hacker IP address. It's not running under that IP address, it's running under the malware.net domain. It's like an iframe. It's inheriting the origin of the actual domain where the image has been served from. So you upload an avatar to Microsoft or Google, and you can now run content from their domain. And that's what Google and Microsoft do differently. I'll tell you how they fix it in a moment. But so look at the traffic one more time. So we got the HTML code, right? And the next thing that happened is it went to Adobe for like a flash player button, and then it went to user profile in malware.net. And this is the Flash client doing this. In fact, you can see it's Flash because it says X Flash version. It's the latest Flash version, actually. So the Flash is going to malware.net, who served this picture masquerades as Flash, which the attacker invoked from the attacker website. And it actually sent a cookie from malware.net. That's pretty awesome. So, hey, malware.net, I want you to give me this page. And by the way, I'm totally authenticated. And then, it comes back with confidential information goes here, right? And then the last thing that happened is, and this is really, really fun. The last thing that happened, it went to Evil Hacker to get another domain, host Evil Hacker log PHP, X confidential information goes here. So you can see it was able to actually write the confidential information from malware.net to the hacker starting from an IP address. And this is all possible because Flash is very fun, and it allows you to load an image from a different domain as if it were a Flash file, and that should not be allowed, but it works. Now, there's a few ways you can fix that if you're concerned about your organization allowing uploads. There's a few mitigations that I can suggest to you. One of them is you can scan the Flash header to see the Flash file. But that does not typically work because there's this guy that a month ago came up with an idea to put a Flash file entirely using ASCII characters. It's called the Rosetta Flash. You can look it up. He basically figured out how to transcode a binary Flash file into ASCII. You can process and validate the image. Allows us to do this to see if it's a real image. But there may be some trickery there. Maybe it has some image headers and then some Flash headers. You can, and this is what mostly, another way you can serve the images as an attachment instead of a line, but then we just cannot see the images, we can only download them, so because it's an attachment, Flash will not render it. And what Google and Microsoft is also do typically is we serve the images in a content domain. So when you upload an image, it's not served from google.com, it's served from Google usercontent.net. And that domain is a sandbox that keeps things from, right, the other way you can just make Flash, that's the thing to do. So, all right, so, time? Okay, do I have 5 minutes? The last demo? 5 minutes? Okay, 5 minutes, I have 5 minutes, all right. Okay, so the URI scheme provides a way to put a virus or malware in a web page. So this is a lot of fun, because this technique allows you to so the URI allows you to separate elements like an image and style sheet. And instead of serving them from a different page, from a different HTTP request, you can actually embed them on the page. So somebody figured out, hey, we should save HTTP requests because they cost us trees and CO2 and all those things. So let's be environmentally friendly. Let's reduce the number of HTTP requests. And instead of putting the images as external resources, we will inline them as data URIs. So what this looks like is something like this: data, and then here you put the main title, base64, here you put encoding, and here you put some base64 data, which contains the actual image. Now, this was ideally, this was intended for images. But somebody figured out that you could do, we figured out that you could do this with more than images, you could do this with binaries. So let me show you an example. Here's a demo. You're going to go with from to this page. It's malbot.net flash download.html, right? So it's malbot. You can see it's a malicious page, right? And it basically says get a Dolby Flash player, download the latest Dolby Flash player. Okay, I haven't downloaded anything yet. I would not download anything from this site. I'm going to click here to see what happens. And when I click, it went to the Dolby page. Okay, and here's the download. So let me show you that again. I'm actually going to make it full screen. I'm going to click it again, open this new page, and it says adobe.com, and there's download, right? So it's basically adobe.com sending me a download. Now I'm going to open this download, and I'm going to show you what happens when I open download. It's bad news, I can tell you that. Download to, okay, where's the download? It must be at the top. Okay, here, boom. So you can see this is the download. It says electrical multiplexer.doc. And just to prove that this is the real download, I'm actually going to delete it. And I'm going to do it again just so you can see it if you missed it the first time. Now it's going to be called download 3 because download 2 already exists. And there's no download 3 folder, so I'm going to unsave it. Okay. I'm going to open that folder, download 3. And there's a Word file. That basically we're going to open. Now watch the screen because it's going to happen fast. So Word file opened, and I get a message on my phone, which basically I'll read it for you. Or you can give it to someone to read it. Maybe you can help them read it.
FRM exfiltration services. Subject: target has been intercepted. Message: Red 7 to Delta 5. The fox is in the hen house.
And not only that, but it's a lot of fun because if you go to net user, there's a hacker takedown user that got inserted. So I'll show you how it's done, but so you can see this is real. I'm going to delete the user. before they kick me out. User, okay, so the user's gone, and I'm gonna run the Word file one more time. Boom, just like that. Look at the user's back, and you get another message. Okay, thank you. So this is all trickery. This is browser trickery and operating system trickery. So here's what's happening. When you click Adobe, this link actually goes to Adobe. Look at the URL right here. It says freaking Adobe, get adobe.com/player download flash. What happens is, if you look at the whole source code, here you have, right, so here you go into Adobe, it's opening new window, says meta refresh, URL, get Adobe, flash player, and then it's putting a timer after 2 seconds after the Adobe page loads, it goes to a different page. That page is not showing the URL because it's not a real page, it's a data URI. The data URI is this thing here. Data, application zip, base64, and this is the base64 encoding representation in HTML of the zip file. And this works with Chrome and with Firefox, modern browsers. So all of this is the malicious file. It's not hosted anywhere, it's embedded in the page. It's beautiful because no antivirus in your server will detect it because it's embedded in the page. It's not a physical file. It's base64 representation of the file. That's the zip file. Now, you might be thinking, well, the zip file, that's all good. So you managed to download a zip file from the Adobe page, right? That's pretty impressive. Adobe zip file. That's pretty good, but how do you get from a Word file to an executable that goes to your phone? That doesn't make any sense. You're probably running a vulnerable version of, Word, and no, this is actually the version. What happens is this is not a Word file, it's actually an executable file. So you go right-click properties, so it's right here, somewhere, type of file is an exe. And the actual extension is lying to you. The extension is exe. It just so happens that an exe that sends a message to my phone and it opens Microsoft Word as a decoy. What's happening is the extension has a right to left Unicode character that inverts the last 6 characters. So if we go to right-click, rename, you will see that it actually highlights the extension in white. That's pretty cool. So how do you do that? Well, basically you come with a name that's convincing enough, like multiplexer, right? And instead of multiplex, and then right-click, insert Unicode character, right to left or right. For people that are from different parts of the world, they read from the right to the left. French probably might have invented that too. And you type COD, which is the inverse of doc.exe. Just like that, you have an executable file that appears to be a doc file, but it's really not a doc file, it's an executable file, right? And if you go to different view of details, it will tell you, hey, this is an application, it's not a Word file. But who reads that? Because guess what? I actually was nice enough to put the icon size match that of Word, so the file matches Word, the icon. So that is what I have for you today. And last year at the Hacker Halted, I presented an attack called Breach, which I think you guys might enjoy, but it might keep me here half an hour, and I'm not going to do that. I'm going to get the drinks, but you can read all about it at requestAnimation.com if you want to read about the side compression channel attacks. Thank you so much.